Welcome to mathematics class, straight line part 12. In continuation with the last class, let us solve some more problems from the exercise 3D part 2. Find the equation of the lines, find the equation of the straight lines passing through 1, 3 and perpendicular to the line passing through the points 3, -5 and -6, 1. There are two bits. One is parallel, another is perpendicular. Now let us find the parallel. Now let the 2 points as A and B. So there is a line passing through these 2 points AB. We have to find another line which is perpendicular to this AB and passing through the point C, that is 1, 3. So we have to find a parallel line which is passing through 1, 3 and parallel to the line passing through this 3, -5, 6, -6, 1. We know that the slopes for the parallel lines are equal. We require a slope and point is there. We require slope. By using slope and point formula, we can find the equation of the required line. So to find slope, let us find the slope of AB. And the slope of AB and slope of the required line passing through 1, 3 are equal. We know that the slopes of parallel lines are equal. So by finding the slope of AB, the slope of the required line is also the same as the slope of AB, as they are parallel lines. Now let us find the slope of AB line. That is y2 minus y1 by x2 minus x1 is the formula. Minus 6, y2 minus y1, 1 minus plus 6, x2 minus 6 minus x1 is 3. 6 by minus 9, cancelling with 3. 3 2 times, 3 times. The slope of the AB line is -2 by 3. Slope of AB is -2 by 3. So the slope of the required line is also -2 by 3, as the slopes of parallel lines are equal. The slope is same. Slope of the line which is parallel to AB is also -2 by 3, as the slopes of parallel lines are equal. Therefore, now the equation of the line passing through 1, 3, passing through 1, 3, and parallel to the line passing through AB. So point 1, 3, that is x1, y1, and the slope m is -2/3. The formula is y minus y1 m into x minus x1. So if we know a point and slope on the line, so this is the formula to find the equation of a straight line. So we know a point and slope of the line. So x1, y1. So y1 value is 3 and slope is -2/3. x1 is 1. Simplifying 3 into y, 3 into 3. So -2 into x, -2 into -1. So bringing all the terms one side, 3y minus 9, -2x becomes +2x, +1 becomes -1, x term and y term, 9 and 1 minus 10. So this is the required equation, which is parallel to the line passing through 3 minus 5 is -1 and passing through 1, 3. So in second bit, we have to find perpendicular line perpendicular to AB and passing through the given point 1, 3 and perpendicular. We have to find the perpendicular line which is passing through 1, 3 and perpendicular to both A and B, where 3, -5, B is -6, 1. Now slope of already, we know the slope, just we found in the previous one. Slope of AB is -2/3 from the previous problem. The slope of AB is -2/3. So this gives slope of CD, which is parallel to AB. When we know the slope of a line, and we can write the slope of its parallel line and with the slope of its perpendicular line. Slope of the parallel line is same and slope of the perpendicular line is its reverse and change the sign. 2/3 becomes 3/2, minus sign becomes plus. So that the product of these two slopes is -1. So simply reversing the slope and changing the sign, we get the slope of parallel line. So this is the slope of required perpendicular line and a point is there. Now equation of the required line, equation of the straight line perpendicular to AB and passing through 1, 3, that is C. So point 1, 3 and the slope of this one is 3/2. Let us take the point x1, y1 and the slope as m. So point slope form, equation of any straight line, if you know a point and its slope, y minus y1 is equal to m into x minus x1. So substituting this x1, y1 and the slope is 3/2, x minus x1 is 1. 2 into y, 2 into 3 and 3 into x, 3 into 1. So bringing left terms right side, we get 3x minus 3 minus 2y plus 6 is equal to 0. X term, y term, 6 minus 3 is 3. So this is the required equation which is perpendicular to the given line passing through the given points and passing through 1, 3. So in this both parallel and perpendicular. Find the line passing through 1, 3 and parallel to 3, 5, 6, 1 and passing through 1, 3 perpendicular to 3 minus 5 minus 6, 1. Now let us take up one more. Find the equation of the line. Find the equation of the line perpendicular to the line, perpendicular to the line 3x plus 4y plus 6, 3x plus 4y plus 6 and making an intercept. And making an intercept minus 4 on x-axis. Equation of line perpendicular to this one. So let the equation of a line perpendicular to 3x plus 4y plus 6 is equal to 0 is, so the for perpendicular line, change the coefficients of x, y, x coefficient right to y, y coefficient to x. So this is 4x, 3y and change the sign between. Plus is there, change it to minus and constant as k. So this is the equation which is perpendicular to the given equation. So this is perpendicular line which is perpendicular to the given line. And converting it into intercept form. So divide with k. So dividing all the terms with k, this can be written as k by 4 plus y by k by minus 3 is equal to 1. Here, the x-intercept, this is x-intercept, x by a, y by b is equal to 1. This is the intercept form where x-intercept is a. So here, the x-intercept, that is a value, is k by 4, and it is given in the problem as minus 4. So this is given, x-intercept is given as minus 4. So equating k by 4 to minus 4, here k value minus 4 into 4 minus 16. So substituting the k value, substitute k is equal to minus 16 in equation 1, we get the required equation. So this is the 4x minus 3y is equal to k. 4x minus 3y is equal to minus 16, or 4x minus 3y plus 16 is equal to 0 is the required equation. Now let us take one more. Find the foot of the perpendicular. Find the foot of the perpendicular drawn from 4, 1 upon the straight line three x minus 4y plus 12. Foot of the perpendicular from the given point now to the line. Let us take the line as ax plus by plus c, and a point P, x1, y1, and the foot as q, x2, y2. Then the foot of the perpendicular is x2 minus x1 by a, y2 minus y1 by b, minus ax1 by1 plus c by a square plus b square. So this is the formula to find foot of the line foot of the perpendicular drawn onto the line. So here the given point is 4, 1. I have to find x2, y2 values. x1, y1 value is there, and the line is there. 3x, 4y plus 12. So only x2, y2 values are not there. We have to find x2, y2. That is the required foot of the perpendicular. So here, this is x1, y1. x2 minus x1. x2, we have to find x1 is 4. A value is 3. y2, we have to find y1 is 1. And b, coefficient of y is minus 4. And substitute the point in the equation. 3 into x, 3 into 4, minus 4 into y value is 1, plus 12, divided by a square and b square. Simplifying the right side, minus of 3 into 4, 12, 4 into 1, plus 12 by 3 square 9, 4 square is 16. 12 plus 12, 24 minus 4. 24 minus 4 is 20 by 25. That is equal to 4, 5 into 4, 5, 4 is 20, 5, 5 is 25. X2 minus 4 by 3, y2 minus 1 by minus 4 is equal to, taking first one and equating first and second, x2 minus 4 by 3 is equal to minus 4 by 5, and y2 minus 1 by 4 is equal to minus 4 by 5. So taking 3 that side, x2 minus 4 is equal to 3 into 4, 12 by 5, and 4 also right side, minus 12 by 5 plus 4, 5 LCM minus 12, 5 into 4, 20, 20 minus 12, 8 by 5, x value. Similarly, taking 4 that side, y2 minus 1, minus 4 plus 16, and minus 1 also right side, becomes plus 1, 16 plus 5, 21 by 5, taking LCM and adding. So this is y2. Now the foot of the perpendicular, is x2, y2, that is 8 by 5, 21 by 5. This is how we find the foot of a perpendicular drawn onto a given line. Now let us take up one more. X minus 3y minus 5, x minus 3y minus 5 is equal to 0 is the perpendicular bisector of the line segment joining the points AB joining the points A minus 1 minus 3 and B joining AB, where A is minus 1 and 2. Find B. So this is AB and find B. So this x3y minus 5 is the perpendicular bisector of the, now this is the given line and this is A minus 1 minus 3. So this line perpendicular bisector of the line segment. So this is B. So this line is bisecting, perpendicular bisector of the line segment AB. The B is nothing but the image of A. So here B is the image of A with respect to the line x minus 3y minus 5 is equal to 0, where let B as x2, y2, whereas A is x1, y1. Now the formula, the image x2 minus x1 by A, y2 minus y1 by B, minus 2 into ax1 by1 plus c by a square plus b square. So this is the image. This is the image you can observe. Only this 2 is different for image and foot of the perpendicular. For foot of the perpendicular, 2 is not there, and for image, 2 is there. So we know x1, a1, except x2, y2, all the values are there. So here, a value is 1, b value is minus 3. Substituting x2 minus x1, x1 is minus 1, x1 is minus 1, y1 is minus 3. And a value is 1, and y value is minus 3, b value is minus 3, minus 2, ax1. So a is only x. In place of x, x1 is minus 1 plus by1 minus 3, y1 value is minus 3 plus c is minus 5. ax1 by1 is nothing but substituting the x1 y1 point in the equation x minus 3y minus 5. A value a square is 1, a value is 1, a square 1 square. B value minus 3, b square is minus 3 square. So x2 minus minus plus y2 plus 3 by 3 minus 3 minus 2 of minus 1 minus into minus 3 into 3 9 5 1 square is 1 3 square is 9. Further simplifying 5 minus 1 minus 5 minus 6 9 minus 6 is 3. 9 plus 1 is 10. 2 1 time, 2 5 times. So that is equal to minus 3 by 5. So here x2 plus 1 by 1 and y2 plus 3 by 3. So equating both, we get two equations. x2 plus 1 by 1 is equal to minus 3 by 5. And y2 plus 3 by minus 3 is equal to minus 3 by 5. So here x2 plus 1 is equal to minus 3 by 5. Bringing 1 right side, x2 is equal to minus 3 by 5 minus 1, that is minus 3, 5 into minus 1 by 5. So x2 value is minus 8 by 5. And y2 plus 3 is equal to multiplying, cross multiplying, minus 3 into minus 3 plus 9 by 5. And y2 is equal to 9 by 5 minus 3, 9, 5 into 3, 15. 15 minus 9 is 6. 15 minus 9 by 5. minus 6 by 5 by y2 value. So therefore, the image coordinates of the image, that is B, is x2, y2. So that is minus 8 by 5 minus 6 by 5. So this is the image. Now let us take up one more problem from Roman 3, first one. Show that the lines x minus 7 by minus 22, 3x plus 4y plus 9 and 7x plus y minus 54 form a right-angled isosceles triangle. A right-angled isosceles triangle. ఈ మూడు సరళ రేఖల చేత లంబకోణ సమద్విబాహు త్రిభుజం ఏర్పడుతుందని చూపించాలి. Let us find the angle between the lines. Let us take it as 1, 2, and 3. Let the equations of the sides x minus 7y minus 22 be the first equation, 3x plus 4y plus 9, second, 7x plus y 54 be the third equation. Now let us find the angle between 1 and 2. Angle between the lines 1 and 2. Let the angle be A1, A2, B1, B2 by under root A1 square, B1 square and A2 square, B2 square. So here A1 is 1, B1 is minus 7, A2 is 3, B2 is 4. So substituting these values, A1, B1, A2, B2. A1, 1, B1, A2, 3. So B1 minus 7 into 4 A1 square, B1 square, A2 square plus B2 square. 1 into 3, 3, 28. 1 plus 49, 9 plus 16, 28 minus 3 minus 25, 50 and 25. So you can take it as plus 25, mod is there. So 50 can be written as 2 into 25, 25 into 2. So this is root 25 is root 25. So 25, root 25 is 25 and root 2. 25 will get cancelled. This is 1 by root 2. So cos A is equal to 1 by root 2, where A is equal to 45 degrees. Since cos 45 is 1 by root 2, the first angle is 45 degrees, and 2 and 3. Now the angle between the lines 2 and 3, where the second line is 3x plus 4y plus 9, 7x plus y minus 54. So here A1 is 3, B1 is 4, A2 is 7, B2 is 1. The formula, let the angle be, second angle B. Formula is A1, A2, B1, B2 by A1 square, B1 square, A2 square, B2 square. Angle between the two lines. So cos B, A1, A2, 3 into 7, B1, B2, 4 into 1, divided by A1 square and B1 square, A2 square plus B2 square. So 3 into 7, 21. 4 into 1, 4. 3 square is 9, 4 square is 16. 49 plus 1. So 21 plus 4 is 25 by, this is 25 and 50. 25 by 25, 50 can be written as 25 and 2. 25 by root 25, 25, 25, and 25 will get cancelled. This is again 1 by root 2. Cos B is equal to 1 by root 2 implies the angle is 45 degrees. Two angles are equal, 45, 45, and the angle between 3 and 1, the third angle, angle between the equations 3 and 1 be C cos C. Now let us write the equations. The third equation, 7x plus y minus 54. First one, x minus 7y minus 22. Here a1 is 7, b1 is 1, a2 is 1 x coefficient, and b2 is minus 7 y coefficient. Let the angle be C. So cos C is equal to mod a1 a2 b1 b2 by under root a1 square b1 square a2 square b2 square. Substituting the values, a1 a2 7 into 1, b1 b2 1 into minus 7 by a1 square 7 square plus 1 square a2 square plus b2 square. 7 into 1 7 minus 7. 7 minus 7 get cancelled. 0 by 49 plus 1 50 50. So 0 by anything is 0. So here cos C is equal to 0. So cos 90 is 0. Or a1 a2 plus b1 b2 is 0. That is angle is 90. They are perpendicular. So all the three angles are there. Two angles are equal, 45 45. And one angle is 90 degrees. One angle is 90 degrees. That is C, A, B, C. So both angles are equal, and the third one is 90. Therefore, it is right angled isosceles triangle. So similar problems you can do. Finding all the angles, you can able to say whether the given triangle is right angle triangle, or equilateral triangle or scalene. We can able to say if three sides are given, and we should able to say what type of triangle is it by finding the angles, three angles. Therefore, given lines form a right angle isosceles triangle. Given lines form a right angled triangle. So in this way you can practice some more problems, similar problems when the three sides of a triangle is given. By finding the three angles, you can find what type of triangle is it, whether it is a right angle, isosceles, or equilateral or scalene. Simply by finding the angle between the two lines, we can find the angle angles of a triangle. All the angles are equal, it is an equilateral. If no angle is equal, it is scalene. If only two angles are equal, it is isosceles. And if any one of them is 90 degrees, it is right angle triangle. So keep watching all the videos right from the first one and try to solve the solved problems from the exercise. They will be almost similar, and prepare your notes. Thank you. Thank you for watching.